have to worry about an asteroid destroying our planet? This is one of the most common questions that people ask me as a scientist. And movies like Armageddon or Don't Look Up make everyone even more paranoid. So what does science say? Well, today we're going to look at a particular asteroid named 2003A1 that is coming close to Earth in 2038. We will discuss whether it might hit our planet and what would happen if it did. And make sure to watch till the end, because I'm going to show you how you can help scientists all around the world keep an eye out for dangerous asteroids. Okay, so let's get right into it. In February 2023, NASA released data showing that there was an asteroid that had a concerningly high chance of hitting the Earth in 2038. The asteroid, named 2003A1, was first discovered almost 20 years ago and has been observed for quite some time. But in February 2023, scientists updated its orbit and noticed that it might be on a collision course with us. At the time, the chances of it hitting Earth were 1 in 600. Now that is not very likely, but it is also not zero. So what's the latest? Has the probability changed? To answer that question, I went to NASA's Center for Near-Earth Object Studies, or CNEOs for short. They have a fantastic website where they share their predictions about asteroids that might hit Earth. Unfortunately, it seems like the headlines in the media in February were a bit exaggerated. On the CNEOs website, you can see that the probability of 2003 hitting the Earth in 2038 has dropped to 0%. However, this doesn't mean that we can sit back and relax. You see, the uncertainty in the orbit of an asteroid leads to a range of possible orbits, which is called the confidence cone. If the confidence cone of an asteroid contains the Earth's orbit, then there is a non-zero chance that it will hit our planet at some point in time. For 2003A1, the current confidence cone does not intersect with the Earth's orbit. However, it might change in the future as we observe the asteroid and update its orbit, and the probability changes accordingly. So just because the probability of it hitting the Earth in 2038 is currently 0% does mean that it will stay that way. It could increase again in the future. But okay, let's assume that the probability stays at 0%. Would we still care about this asteroid? Well, the answer is yes, we would. Here is why. Let S say that the probability of 2003A1 hitting the Earth in 2038 remains at 0%, meaning that there is no chance that it hits us next year. That still leaves the possibility that it could hit us in the future. The current prediction for 2038 is 0%. But the uncertainty in the orbit of the asteroid means that we cannot rule out the possibility of it hitting the Earth in the next couple of decades. But even if it never hits Earth, we still care about 2003A1 because it is part of the Apollo family. Asteroids in the Apollo family are known to come very close to Earth, and it would be good to know how many of them there are and where they are located. Also, we often use these near-Earth asteroids as targets for our spacecraft to study them up close. For example, the Japanese space agency JAXA plans to launch the Destiny Plus spacecraft to study the asteroid 2003A1 in 2024. So while 2003 might not hit the Earth in 2038, we still care about it for other reasons. Okay, now let's talk about what would happen if 2003A1 did hit the Earth. According to NASA's Impact Risk Assessment, the asteroid would be about 4 kilometers wide. And fortunately, according to the simulation that they ran, it would not cause any global devastation. However, it would certainly affect the area where it would land. But you might wonder, how big is 4 kilometers? And that really depends on your perspective. The biggest asteroid that has ever hit the Earth is estimated to have been about 10 kilometers wide. It left a crater that is now called the Chicxulub crater, and it killed off all dinosaurs except birds, of course. If you want to learn more about that event, you should check out my previous video. Now, I think that 4 kilometers sounds big, but if we compare it to the size of the Chicxulub asteroid, it is a lot smaller. The asteroid that killed the dinosaurs was estimated to be 10 times as massive as 2003A1. Now, the energy that an asteroid carries when it hits Earth depends on its mass and its speed. And when comparing the energy of different asteroids, we often use the TNT equivalent. You may have heard of atomic bombs and how they are measured in kilotons or megatons of TNT. And this is also how the impact energy of asteroids is measured. The biggest asteroid that has ever hit the Earth would be 100 million tons of TNT 2003. A 1 would only be about 400 tons of TNT. Now that doesn't sound like much, especially since Las Vegas uses about 400 tons of explosives every year for their New Year SCV. However, the impact energy of 2003 A1 would be concentrated in a small area, and it would be devastating for the region. And while a large asteroid hitting the Earth would lead to a mass extinction event, 2003 A1 would not. If it did hit the Earth, it would be a terrible disaster for the people living nearby, but it wouldn't wipe out any species. And here's another piece of good news. According to NASA, the asteroid would probably break up in the atmosphere long before it reaches the ground. If it didn't, it would leave a crater that is about 6 kilometers wide and 40 meters deep. And the energy that is released when the asteroid breaks apart would cause substantial overpressure and thermal effects. The good news is that it will probably break apart at an altitude of about 31 kilometers above the surface of the Earth. And while that is very high, it is nowhere near the Kármán line that marks the boundary between the Earth's atmosphere and outer space. If the asteroid broke up above the Kármán line, then it would not cause any damage on the ground at all. So remember that the next time you're rewatching a movie about spaceships landing in the atmosphere and causing massive destruction, it would not happen if the spaceship broke up above the Kármán line. Now, if the asteroid didn't break up in the atmosphere, it would release about 100 billion tons of rock into the air. And this rock would reach temperatures of about 4,000 degrees Celsius. Not that you could survive that, but just to give you an idea of how hot that is about half the temperature on the surface of the sun. And of course, we couldn't see anything after that because the dust in the atmosphere would block all light. To make matters worse, the dust would also reflect a lot of sunlight, which would lead to a period of darkness during the day. Just imagine you're having a picnic outside and suddenly it gets dark. Then you look up in the sky and you see huge pieces of asteroids slowly falling down from the sky like rain. I think that would be pretty scary, honestly. But while there would be a lot of flying rocks, there would not be any significant climate change. And that is mainly because the asteroid would not bring that much mass to the atmosphere. If it did, then the amount of carbon dioxide in the atmosphere would increase and the Earth would warm up. But in this case, the amount of carbon dioxide in the atmosphere would only increase by 0.001%. So no worries there. However, there would be something you could worry about. When the asteroid hit the atmosphere, it would leave behind a cloud of debris, and this debris would circle the Earth for months. And every time the sun hit the debris, it would sparkle like a beautiful firework. But then again, it would only last for a few months until the debris burned up in the atmosphere. And what would you see if you looked up in the sky? Most likely, you would see pieces of the asteroid burning up in the atmosphere and leaving behind beautiful trails. If you wanted to see the asteroid before that, then you would need a powerful telescope. And luckily for us, such telescopes exist. And the best thing about them is that you don't need to own one to use it. I often get asked what kind of equipment I use to make my videos. And sometimes people are surprised when I tell them that I do not actually own any of the equipment. Instead, I use publicly funded facilities that are open for anyone to use. This includes the telescopes that I use to collect my images of nebulae and galaxies. These telescopes are usually located at observatories in remote locations that have dark skies and minimal air pollution. For example, I recently visited the European Southern Observatory in Chile and got to use some of their incredible telescopes. Or I also visited the W.M. Keck Observatory in Hawaii. and got to use their impressive instruments. If you want to learn more about these observatories and how you can use them yourself, I encourage you to visit their websites. You can also check out my video where I show you how I use publicly funded supercomputers to make my videos. So while an asteroid hitting the Earth in 2038 would be a very unfortunate event, it would not be the end of the world. We would just have to deal with a lot of flying rocks and a few months of sparkling sky. But it would be an incredible opportunity for scientists to study an asteroid up close. And who knows? Maybe we will find out that there are entire civilizations living inside asteroids. That would be pretty cool, right? And if you want to know more about what would happen when a large asteroid hits the Earth, then check out this video where I go through the consequences of the Chicxulub impact that killed the dinosaurs. Thanks for watching.